All right. So we will start with an introduction to statistics. And in this class, we will talk a bit about statistics, the importance of statistics in data science and machine learning, the types of statistics, and what are the plots we have in statistics. Before we start, if you have any question, do drop me a note over chat. Now, the objective of today's class is to build a basic understanding of statistics. And if you have attended yesterday's class, I have already told you that there was nothing called a data science engineer, or a machine learning engineer, or a data scientist, or a machine learning research scientist, nothing like that. 10 years back, it was all statistician, right? So statistics is the base of data analysis and machine learning and artificial intelligence and data science, whatever you call today. Okay. Now we will learn the introduction of statistics. What is the importance of statistics in data analysis and machine learning? Data in statistics, types and sources, types of statistics, an introduction to descriptive statistics, which is central tendency, spread and shape, and plot of different types like histograms, bar charts, scatter plots, and box plots. Okay. Now, one of the fun fact about statistics is there are lies, there are damn lies, and then is statistics, right? Mithilesh Patra, could you please explain cross selling and I hope it is upselling in banking domain with an example? Yes, I will do that. I will do that. I will just park this question for a later point of time, probably an hour when we all are probably a little sleepy, right? So I will definitely ask a question. Okay. Thank you. And as I said, there are lies, there are damned lies and statistics, right? Why so? Because with statistics, you can, prove anything. And whenever you go to a debate, you will probably see people using a lot of statistics to make sure their point are valid, right? One of the fun fact I must tell you is, say, for example, there is an election, right? And in that election, if one party wins and the other loses, right? Even if the losing party uh, gets less seat than the winning party, they will tell you, okay, what happened, in the previous election we got 25% votes, and this time we got 31% votes. Even though we have lost, you know we have received a better mandate from the people. And this is how statistics is used to make agenda, make interesting facts about anything and everything, right? So this is how statistics is fun, because as Mark Twain says, that there are lies, there are damn lies, and there are statistics. So with statistics you can prove anything if you have the capability. Moving on to the next one, introduction to statistics. Now, statistics is the science of conducting studies to collect, organize, summarize, analyze, and draw conclusions from a data. So through statistics, you can basically, conduct studies. You can collect, organize, summarize the data, and we'll see how we can collect, organize, and summarize this data and draw conclusions from this data, right? And here is a cartoon which says, "Holy shit, man! Look at this. Study finds 50% of people are bored by statistics." And that's true, right? Because you cannot infer anything good with statistics. It's a lot of data. I don't want to say that you cannot infer anything good, but rather this is something boring, right? Obviously, if I give you a table of data with a lot of inferences, you might feel boring about it. So that's why we have a lot of visualization and pictorial diagrams, which make sure that statistics is better with diagrams, not with data. Okay. Now, importance of statistics in data analysis and machine learning. Now, if you see statistics in data science, a whole horizontal is dedicated towards statistics, like data mining, knowledge discovery, pattern recognition, and then we use these machine learning models on top of these statistical data to find out prediction. We want to cluster the data, or we want to do any classification of the data. Now, how does this data mining, knowledge discovery, and pattern recognition helps? See, whenever we want to mine the data, say for example, I want to create a product which is a face recognition product, right? And this particular product will recognize any face which probably a Facebook tagging algorithm where it tags the face of a person automatically, right? We all know whenever we upload a picture on Facebook, it automatically recognizes my friend and my wife and my mother, right? Why? Because it has learned over the years, whenever you have uploaded these photos, or these individuals has uploaded their photos and they are my mutual friends, right? So statistics helps in data mining. So this will be mined, right? Now, imagine you have created a product which only works in India, okay, or rather in our Indian subcontinent, because all of us probably in the subcontinent looks more or less the same, right? We have more or less same features. But imagine this doesn't work in Africa, or it doesn't work in America, or in Europe. So your product will be a fail, or a failure. So you have to have some certain statistics about your data, saying whenever I created this model, I trained the model with 1 million data points from America, and 1 million data points from Africa, and half a million data points from Europe, and probably 5 million data points from Asia, right? So this is how you create some statistics. You create some randomness in the data. We'll learn about what is randomness. We will uh, create certain randomness in the data, right? And through that, we will mine the data, right? So whenever we mine the data, we make sure that we have enough discovery of our data, we have enough randomness in our data, so that there is no partiality, right? Whenever we create a product. Now, through that, we will create some knowledge discovery, right? What is this knowledge discovery? Whenever you look into the data, you probably have to think about, or think aloud, that what type of discovery we can make with the data, right? Say probably if my client gives me a table in a SQL database and says, can you check, you can do anything about innovating my product? Thus can this data make sure that it has enough knowledge to create certain models which can help me in upgrading my product, or create innovative decisions about my product, right? So I have to certainly find out something about my data in that data. So in that data, I can find out how many males and females are there. For example, if it's a retail uh, data, I can find out how many males and females are there, how many males are purchasing in the store every month, right? What is the revenue we are getting with respect to people from age group 24 to 34, right? And these are the type of knowledges you can discover, and then you can tactically handle all of these, right? So this is called knowledge discovery. So I can give you one example. So what happened is, Target, initially when it was operating in United States, there was a hurricane, right? There was a hurricane alert, and all of a sudden, people freaked out, and they just ran out and started buying, whatever they have. Okay, and they have seen amazing buying pattern, right? So it was initially not discovered by the team, but they saw, all the beer bottles are, stocked out. A lot of jelly is stocked out. A lot of chocolate pies are stocked out. So they understood that the buying pattern of that particular area is different from the buying pattern of the other areas, right? Uh, those who are in Delhi, you will find out that probably a lot of students stay near Mukherjee Nagar, or Lakshmi Nagar, these areas. So the buying pattern of that place will be different from people who are staying near Connaught Place, right? In Bangalore, if you stay in Indranagar, it is a highly posh area. So probably the buying pattern at Indranagar is lot different than buying pattern at Jayanagar, where a lot of business class people stay. So this is how I am trying to say the knowledge discovery. So whenever target, when the next time target, you know analyze the data, this was the first time, probably this was in 2001 or 2000 or early 2000, right? When target analyzed the data, they found out that these are some interesting patterns within the data, and how they used the analytics to stock their products the next time whenever there was a flood alert or a hurricane alert, right? So they stocked a lot of these apple pies, yeah, chocolate pies, and then um, um, jellies and beers, right? And through that analytics, they first started with a team of 5 people who were specifically looking into the data and giving them results. And at that time it was not that advanced, and there was not so much budget into the IT industry at that point of time. So they were manual analysts who were manual researchers who were looking to the data, and later they went to the statisticians to sort of create an industrial level project out of it. So this is called a knowledge discovery. You discover the knowledge from the pattern of the data. And obviously I talked about pattern recognition, where you understand if there is any pattern in the data, right? And through that statistics you can obviously create some prediction, like how much stocks I should have in case of a hurricane, or on a weekends or weekday, right? So these predictions you can do. You can cluster the products together, like probably I should bundle these type of products together. You have ideally seen, whenever you go to a retail market, you'll probably see a shampoo and a soap and a toothbrush, and 3 or 4 more items are bundled together, and then they give you some 30% discount out of it. So you will see that these are clustered items. Next is the classification, just to make sure that which type of products people prefer from different genre, right? So that's why you see a lot of these high margin products at the billing counter, right? They have more margin, so tendency of people buying those products are higher. So these are the type of this is how statistics helps us in data science. Okay, now coming to the machine learning versus statistics. Machine learning and statistics always go hand in hand. Okay, so first you have to have some statistics to build a case for your hypothesis, that okay, whatever I'm assuming is going to be true based on some sample data, and then you infer that yes, it's going to work on a large scale. You probably build this over a machine learning model. Okay, this is what the importance of statistics in uh, machine learning. Now, statistics is a grammar of science. So as I said earlier, that statistics goes hand in hand with machine learning. So if you don't understand the grammar of any language, you won't be able to speak or write, right? Or read. So that's why statistics is very much important for the for science. And when we say science, it's data science. Okay. Now, where is statistics applied? Statistics is applied everywhere. You can find 5 references here, but ideally speaking, it is found everywhere. Okay, in medicine, in businesses, in weather forecast, in stock markets, and health and social sciences, right? Everywhere you will see statistical application. You remember, if you go to any news channel, or probably if you watch any news channel, uh, pro, or any of these mobile applications nowadays, you'll see they will talk a lot about statistics. They'll say, okay, if I go to CNBC and I start watching CNBC, they'll probably say, okay, you should buy this um, stock called, say, Tata Sponge. Okay, and they will give you probably 20-30% return. It's low because the demand is not that high, and every year if you see the seasonality, this time the stock price is always low, but in the month of August and September it will go high, and then you can make 30% or 40% profit. So these are all they are talking in respect to statistics, right? But obviously sometimes when you learn about time series, you'll understand that at times there are exceptional cases like COVID. Nobody predicted it, and that's why the stock market went down on 23rd of March 2020, right? And whatever portfolio you had of 100% profit probably have went down to 100%, 50% loss, right? So these are some of the things which we have to understand on the basis of statistics. Now, how is statistics applied on medicine? Now, drug cure rate over 10 patients, WHO research on epidemic spread, measure of improvement in TB cases across the world. So everywhere statistics is applied. And how this is done? Say, for example, you have a drug, right? Or you have um, a vaccine which has recently came out, and obviously you cannot test on the entire population of India. Say for example, an Indian vaccine, right? Uh, has came out and they want to test it, so they will seek volunteers and then test it on a certain population, and again they would have some randomness in the data, right? Say probably they will have volunteers, 100 volunteers from one state and 200 volunteers from other state, just to keep making sure that the demographics is into picture. So they will have random people from random places, and they will seek volunteers who will test the drug for them, or the vaccine for them, and based on that particular sample. So if you create a sample size of say 3,000 people of entire India, right, and your drug is working very well with 95% or 97% accuracy, with very mild symptoms for those 5 or 3% or 10% people, right, then you can go to WHO and or ICMR and say, okay, my vaccine is working perfectly, I think we are good to roll out, and give the doses to each and every Indian, right? So this is how statistics is applied. So based on the 3,000 sample size, you're making a judgment, you are passing an inference, right? And based on that, we make sure that whether to start with the bigger model or not to start with the bigger model, right? Same goes with stock market. As I said, understand performance of a stock over time, average price of automotive stocks, study Infosys stocks over a period of 52 weeks. So you have to study your stocks. You have to make interpretation about your stock, whether the stock will go up or stock will go down, right? So these are the instances where statistics is applied. Now, where is statistics applied? Statistics is applied everywhere. If you see your Apple Watch or your any smartwatch, for now Fitbit, right, you'll see a lot of statistics which says, probably in the last 5 weeks you have burned this much calories, right, and this week you are probably down, you have to catch up, you set 10,000 steps and you need to walk every day. So these are all the statistics which you see every week, every month, every year, and from that you can make assumptions whether you are progressing or you're not progressing, if there is any problem with it. That's all about it. So statistics is applied everywhere. Okay, now coming to the data in statistics. As I said, what is data in the last class? It's actually the raw ingredient, right? If you want to make pasta, the raw pasta and vegetables and the sauces all are your raw ingredients. The data is a collection of information such as facts, number, words, measurements, observation, or even just description of things. So anything and everything is data. The words which I am talking right now, it can be a data. You can do a transcript analysis, convert my voice to a word form, right? And from there you can create a statistics that Alankar has probably talked a lot about statistics, and he uses words like probably, and then these are the words he uses more often. So you can create certain information, you can create certain knowledge about what I am talking in the entire class, right? So this is all about data. So data is a collection of information, and anything and everything is a data. Now, data can be of two types. One is the primary data, and the second one is your secondary data. So what is a primary data? We need to understand that from a data perspective, primary data is a data that has been collected firsthand by the researcher for addressing the population at hand. Okay. For example, if I am taking an interview, Okay, by the way, I have an interview tomorrow. Okay, yeah, thank you. So I have so if you talk to a certain individual, or if you talk to certain, you know, group of people, you collect the data firsthand. Okay, when you collect the data firsthand, it is called a primary data. When you observe the data on your own, this is called a primary data, right? If you ask, questions to any of, board members or stakeholders or your colleague, you are actually having questionnaires, right? And this is your primary data. You have a focus group discussion, right? At times, whenever I start a machine learning project in our organization, I always have a focus group session, right? I am really not fond of, having multiple meetings every day or every week, right? But I always start with a focus group discussion to understand, what individuals are talking about. Even an intern has a lot of, new ideas. Even a person who has 20 years of experience has a lot of ideas, and we have to bring in constant innovation. If there is new tool in the market, if you know if there is new algorithm in the market where we can use it, right? We all have that focus group discussion to make sure that all the ideas are first pitched in, and then the senior stakeholders can look into it. And we can also make some point to our stakeholders that, probably we should try this aspect which we haven't done earlier, might give us better results, right? We have to always take chances. And fun fact is that if I create, 10 machine learning algorithms, or I have 10 projects in under me, 2 or 3 only goes to production. So machine learning is, all about making the right decisions, taking chances, even if you know that, this is not going to work. This project is going to be scrapped. If any research product, we do a lot of research products for our client. So if we think that, this project is not going to work, not a problem, right? It is not a, software development product that, there has to be an answer. At times there are no answers for any of the client problems, right? Or the problems or the solutions which we provide cannot be, done without larger investment. So at times some of the machine learning or majority of the machine learning models does not see the light of production. When I say production, it does not, goes to a live project. Okay? So as a researcher, you have to do these things, and then you have to do a lot of case studies. As you see, my 7 days of my week, probably 20 to 25 hours goes into case studies for my own, case studies for my company, for my organizations, case studies for other edtech companies for which I work for. So these are the type of primary data which you collect. So any type of data which you are collecting firsthand, okay, that is called a primary data. Okay, now coming to the secondary data point of view. Now secondary data is something which is already collected by readily available sources, right? So if you see, if you read any research paper, right? If you step into, data science or machine learning field, you have to read a lot of research papers. So if you read a lot of research papers, these research papers are actually created by someone else. So they have done their primary analysis, and you are doing the secondary analysis, right? Diaries, probably if you have watched the movie Gajni, you'll see that there was one lady called Jia Khan who, used to read the diary of Amir Khan. So that is called a secondary data, right? So secondary data is um, something which has been already collected by someone else, and you are taking, that data as your source. Then letters, we had a lot of letters earlier, but nowadays it's all about WhatsApp and messages. Next is web info. Whenever I used to, create, I am already creating a lot of case studies. I go to the web, read about individuals, specifically read about what the CTO thinks, right? The chief technical officer. Because I also, sometimes incline towards more of technology oriented discussions. So I read a lot about what the chief technical officer thinks about the product, right, of that particular startup or any grown organization. So you have a lot of web information. So if you want to research anything about data science and machine learning, you can go to good sources like Analytics Vidya, or Analytics India Magazine, or India GOV. So these are all type of data which gives you secondary information. And then again, you have census data if you want to get to know about the demographics of a particular area or a country or a region, right? So these are all your secondary data. Now coming to the types of data, there are two types of data. I have already talked about very briefly in the yesterday's class that we have two types of data. One is quantitative data and the next is qualitative data, right? What is a quantitative data? Anything which can be in quantity, right? Something which is, you know, which has a measure. For example, we talked about discrete and continuous in regression and classification. So in regressions, we have a discrete. Discrete are something which is how much and how many. Say for example, how many horses? You will say two horses, right? How much money? You will say $10,000, right? Continuous values are not discrete; they are continuous. For example, your weight. Your weight can be 76.5 kgs. Your weight can be 76.55 kgs. Your weight can be 77.1 kgs, and there is no particular range that my weight is only going to be 72, 73, 74, 75. No, I am going to have a data which is not within which is not discrete, rather it's continuous. It's continuously moving over the scale, right? Like your height, your weight, or your salary, for example, right? So these are the type of data. I'm sorry, I made a mistake. Quantitative data is for regression. So whether it's discrete or continuous, I mistaken the fact that continuous and categorical are different. So for categorical, you will have a classification problem. Okay, so for now, try to understand that quantitative has two parts: discrete and continuous. Discrete is something which is 2, 3, 5, 7. So these are all discrete values. And continuous is something which does not have an inbound value. It can be anything over the scale. Okay, next is your qualitative data, which tells you about the quality of the data. Quality as in the features, whether it's a male or a female, right? Ordinal values, where you can say good, better, or no, poor. So the customer ratings which you generally get these are all your qualitative data. It gives you the quality. Okay, moving on to the data quality issues, we have touched about it in the previous class that some of the problems with statistical data is there are duplicacy in the data, there are inconsistent data. For example, duplicity as in redundancy leading to resource wastage. So for example, you have fetched a data from a database table and you think I have 1 million records or 10 lakh records, I can do wonders with this data. Okay, and then you got to know that almost 80% are redundant. So you are left with only 2 lakh data. Okay, and you cannot do wonders with it. So duplicacy is the problem. Next is inconsistency. So withdrawal of 10 rupees not reflecting in a net banking amount. So you have fetched all the data for a retail customer and you have started analyzing it, and all of a sudden you got to know that data for a few customers are missing, or data for particular date ranges are missing. So you cannot do analysis because it is inconsistent. Next is the correctness of the data. Age, income as a negative number. So age cannot be negative, right? Income cannot be negative, right? Next is timeliness. Facebook forms given to students from instructor. Feedback forms given to students from instructor. So if you have received a feedback form and if you're not filling the data in a timely manner, then probably that particular uh, data might not make sense. Say for example, I am your instructor in today's class, and next week some other instructor comes into picture, right? And he gives you a feedback form. Okay, fill this for me and give me the rating. And that instructor is terrific, right? Much better than me. Okay, but you, instead of filling his feedback, gave my feedback that this Alankar guy was a terrible um, instructor. So the timeliness, you can understand like the time is also important. So timeliness is something which you need to understand from a data quality issue as well. Next is the missing values. Stock prices have risen, but displaying low on front end. So if you have inconsistent missing values in the data, say for example, mentioned here, stock prices have risen, but it is not reflecting correctly in the front end application or the tool which you see over the web, right? So these are some of the data quality issues. Now coming to the main point of statistics, what is that? Population and sample. Okay, what is a population? Population is actually the entire universe of your test. Okay, so for example, as I told you about vaccine, right? So there is a new COVID vaccine which has came into picture, and you want to test it out. Okay, but obviously you cannot test it on the entire population. So what you'll do, you will take some random selection. Whenever I say random, it means it should have enough data from all over India. You cannot just take some people, just outside your factory, or Serum Institute in Pune, and then say that, oh, this is working so well and we can roll it out for other people all over India, right? So you have to understand that random selection is very important. So you have taken some random selection and you did some analysis on top of it and say, out of these 100 people, only one has, a mild symptom of fever, and all 99 are doing good. And there has been some immunity in their body. So you can say, yes, this will work for the entire population because you are 99% correct with it. Obviously there are more to it. You have to do a lot of A/B testing just to make sure that you are not taking only 100 samples, but rather you are testing it on batches of 100 people, over 100 batches or 10 batches or 50 batches, and then testing these or checking the statistics of each of these individual batches. But for now, try to understand that we have only one batch of 100 people. You test it out, 99 for 99 it works perfectly well, and you draw inference. You draw inference that it is probably going to work with 99% accuracy over a population of 131 crores. Okay, so the population mean is denoted by mu, sigma, and pi, right? Population mean, standard deviation, and population proportion. And the sample mean, standard deviation, and proportion is reflected through x bar, s, and p. Okay, we'll talk about it in depth in the subsequent classes. Now, what is a population? What is a sample? So try to understand this with the wait time for all 566 cars passing through the drive-through. Okay, so uh, you are a person who is standing just outside McDonald's, and you have a population of 566 car, and you need to find out what is the wait time of these 566 cars. Okay, and you cannot just go and check out for all 566 cars, because that might not be a good scenario for you. You will probably test it out for 100 cars, right? So you have a sample of 100 cars and the entire population is 566 cars, right? Now, average waiting time for a population of 566 cars. This is called the parameter. So anything which is related to the population, okay, is called the parameter. And anything which is related to the sample is called statistic, not statistics. Okay, there is a difference between statistics and statistic. Okay, so the wait time for the population, right? The wait time for population is called parameter, and the wait time for sample is called statistic. And this is not only for wait time; it can be anything. So anything related to population is called parameter, and anything related to sample is called statistic. Okay. Now, what are the different types of statistics? There are two types of statistics. One is the descriptive statistics, and the other one is the inferential statistics. Okay, so before I go to descriptive statistics and inferential statistics,
We'll take a small break of, probably 10 minutes and we'll regroup again. But I will try to answer one question which is asked by Mithilesh. Could you please explain cross-selling and upselling in a banking domain with an example? Okay. Say, for example, in a banking domain, you can have different type of products. Okay. In banking and financial management, if I take a very easy task or a very easy example, uh, say for example you are working as a relationship manager, or some individual is working as a relationship manager in the bank. They have certain targets. You have to make sure that there is a, recurring deposit of 5 lakh rupees under your name, right, or under your portfolio or under your umbrella. And there should be, at least of 5 lakh rupees of new RD, FD or fixed deposit, right? Or you have to sell this product, new product which has come, this LIC product, or this insurance product which has came for, HDFC, and you have to sell it. So there are two things. One is cross selling and one is upselling. I'll come to upselling first. Upselling is where you up your game, right? Up your sales. So for example, if you call up individual and say, probably my relationship manager calls me and say, Alankar, would you like to do an, a recurring deposit of with our company? Say, I will say, no. And then he will say, probably please start with, 2000 rupees per month. Okay. Won't be a problem. You just make an RD of 1 year, 24,000 rupees, and you'll get, say probably 24,000, 25,000 rupees after a year end. And um, this will be enough. And I said, okay, what is the rate of interest? And he will say probably, 5.5%, something like that. Now, when I am okay with, 2000 rupees, and he just, hangs up the phone and, gives me some form to fill up and everything is done. Okay. Next month, again, he comes up to me and say, Alanka, you have this 2000 rupees RD. Can you make it 5,000? We can give you better rate of interest, probably 5.7%. Okay. So this is where he's upping the game. He's upselling his, product. So from 2000, he's making it 5,000. Okay. This is an upselling. But what is cross selling? So in the next month, say when I bought that, in the first month I bought, 2000 rupees recurring deposit every month, or I have taken 2000 rupees recurring deposit. The next month, instead of, he pitching me to buy or take additional 3,000 rupees recurring deposit, he gives me an option to, um, purchase 5 lakh rupees or 1 lakh rupees fixed deposit. So that is actually called a cross selling, where you have in existing product with a customer and you are trying to sell, you know um, different product altogether. So recurring deposit and fixed deposit are different. So if you take in that product perspective manner, okay. So this is upselling and cross selling. Now this might be very much different if you work for a portfolio based, bank. Say for example, I have, a broker with me. Okay. Nowadays people are, used to buy stocks in this Zerodha and all, but still the influential peoples always have a broker with them. So if a broker calls um, a, a customer and says, okay, boss, why wouldn't you buy a new mutual fund which has come into the market? You already have a stock, you want to buy a mutual fund, it will diversify your portfolio. And so this is called a cross selling, right? But if I have already a hedge fund, if you don't know about hedge fund is type of a mutual fund, but it's altogether a different game. We cannot buy, normal public cannot buy a hedge fund because there is a lot of risk involved in it. So if I already have a hedge fund of say probably 10 lakh rupees invested, and they want me to invest more 10 lakh rupees in the same hedge fund or in different hedge fund, this is again called a upselling. So I hope you have understood something about upselling and cross-selling in the banking domain. Let's start with the next topic. And before we start, let's let's all have a Menti session. In case any question, do let me know. Okay. Okay. If any case anyone else wants to join. Okay, let's start. Which of these is an example of categorical variable? Flavor of soft drink ordered by each customer at a fast food joint. Height measured in inches and points scored by each player. That's right, soft flavor of soft drink. I hope this was the time was not that much, so I have to change it. Don't worry. Moving on to the next question. Answer fast to get more points. The entire group of interest for statistical conclusion is called data, population, sample. Just now we have learned the entire group of interest is called population, right? The entire group is called population and the subgroup is called sample. Moving on to the next one. All right. A subgroup that is representative of a population is called. Now this is easy. A subgroup that has a representative that is a representative of a population is called sample, right? Moving on to the next one. All right. Interesting name, dinosaur. Okay. Answer fast to get more points. Statistical inference is estimate and conclusion based on data from a sample, estimate and conclusion based on data from a population, pictorial displays that summarizes data. Right, so statistical inference is always from a sample. So you take out certain data as sample, make certain assumptions, and if it is true, you may draw a conclusion for the entire population. Okay. Don't worry about it if you have not got the right answer. It is all a game of time. All right. Moving on to the last one. Answer fast to get more points. Two types of statistical variables are categorical descriptive, categorical numerical, descriptive and numerical. The right one is categorical and numerical. So there are two types of data, right? One is categorical and one is numerical. Categorical is for classification and numerical is for regression. Okay. All right, so that's the end of our first. Okay, good job. We have Naz, and we'll move on to our slide. Oh, okay. My charge. I need a charger. Just give me a second, guys. Okay, I'm back. So there are two types of statistics. One is descriptive statistics and one is inferential statistics. Today we will focus on the descriptive part and we'll walk you through what is, descriptive statistics. Now there are three, types of descriptive statistics. One is called the measures of central tendency. The other is called spread, measures of spread. The other is called measures of shape. Okay, let's look into each of them. The first one is your measure of central tendency. Now, what is this measure of central tendency? Measure of central tendency is something which is related on how the data is, spread across the range of, from the starting to the end. Okay, and we have two types of descriptive statistics. One is the measure of central tendency and one is the measure of dispersion. Central tendency tells you how the data is, populated towards the mean or towards the center of the particular distribution. You will understand this with a visual representation. Now, measures of central tendency can be mean, median, mode, and to that you can also have harmonic and geometric mean. But the three main aspects are mean, median, and mode. The measure of dispersion again is range, standard deviation, um, and quartile deviation and the mean deviation. Okay, let's understand this. So as I said, the major three chunk is mean, median, mode for central tendency. Now what is mean? Mean is the average value in the data set. Okay, so if you have three, kids out here and they have a weight of 28, 32 and 40 kgs, you can take the mean of them and your mean is going to be the sum of all these values divided by the number of values. This is the mean, as simple as that. Now what is the mean in case of say a transaction? So you have 144 $100, $98,000, sorry, $144,000, $98,000, $204,000 all the way to $100,000. And as you can see, you can just sum up these 7 values and divide by 7. So the sample mean salary is going to be $571.3. Okay. Now, if I add a very extreme value to it, right? So if you see this data, right, all of them are pretty much okay, nearby, and the sample, mean which you got 170 odd thousand value is also, very much, in between these values. Now, if I add a very extreme value, so out of nowhere, if some salary comes into picture of say, um, um, which is way beyond, okay, here it is a million, right, $1 million. So now once we have a single salary, say probably the salary of a of a CEO, right? If it comes into picture, you can see the sample mean has changed from $170,000 to $268,000, right? More, $100,000 more, almost $98,000 more. So mean is always affected by extreme values, okay, or outliers. Try to understand that mean is affected by the outliers or extreme values. Now coming to the rescue, we have median, which is the second central tendency. Now mean is the positional average and refers to the middle value in the distribution. Okay, so if you organized our data in ascending order, 28, 30, 32, 38 and 40, you will have the median, which is the middle value. So out of these 5, the middle value is going to be the third value, right? Now, same example, if you see with the outlier data, which is highlighted in yellow, you see the median value still is going to be $155,000. Why so? Because if you arrange these values in ascending order, so first will be $98,000, and then we will have $100,000, right? And then $144,000, then 155, 177, 204, and $1 million, right? So the mid value is going to the fourth value, which is $155,000. So median is the mid value in any of these data points. Okay, we'll come to that when we have a even set of values. So this was for an odd set of values. So we have only 5 values here, 7 values here. So this is the odd scenario. What if we have a even scenario? Okay, let's see. Now, mode is the most frequently occurring value in the data set, right? So if you see 28, 32, 32, 32, 40, so 32 occurs 3 times, right? So that's why the mode is going to be 32. So mode is the most frequently occurring value in the data set. Okay. Now, take an example. A sample of 20 groups were selected at random. These data are people with, 2 people, 4 people, 1 people, 2 people, and so on. There are 2 modes, 2 and 4, each occurring 6 times. So if you have a data point where, as I said earlier, that 32 was occurring the most. So that's why 32 is the mode. But here you see 2 is occurring 6 times, 1, 2, 3, 4, 5, and 6, right? So this is the maximum. And if you check 4 also, it is occurring 6 times, 1, 2, 3, 4, 5, 6, right? So 6 times 2 and 6 times 2, 4, right? So we have 2 modes in this particular data set, and the manager will decide on 2-seater and 4-seater tables to be arranged in the Plashio. Why? Because we have more number of combinations for 2 and 4, so you have to rearrange your dining in such a way. Now, what is the practical use of measures of central tendency? Right? The measure of central tendency is more about understanding data spread around the center in data analysis, replacing any missing values in the data analysis, showcase performance of players across their careers, study salary spread across the company. So these are the different use cases where you can take the example of or take the help of central tendency, whether it's mean, median, or mode, right? And one is this, the second one is called the data imputation, where say, for example, if you have a column with the salary of 1000 of your colleagues, thousands of your colleagues, and then 4 or 5 of them are missing. So what you can do, you can quickly find the average of rest of the 995 people, and then quickly put that in the missing values, right? So in that ways, you will be able to do data imputation, right? Next, we'll look into the measures of spread, right? How the data is spread. So measures of variability provides information about the degree to which the individual scores deviate from the average value in the distribution. So the first one is range, second is interquartile range, third is variance, and fourth is the standard deviation. Let's see what is this with examples, okay? Now, if you have a range, what it means is it is a difference between the highest and the lowest score in a distribution, which is 45 minus 2, which is 43, as simple as that. So range is the difference between the maximum and the minimum value in a data set, right? So there are 2 plant managers who are asked to record their plant production output for 5 days. Okay, and then plant A is there and plant B is there. And you can see the maximum and the minimum range for plant B is 23 minus 27 minus 23, which is 4. But for plant A, the maximum and minimum difference is what? 15 minus 35, which is 20, right? So it has more range, or the more deviation. So you can probably look into the data set and ask the plant A manager why there is so much deviation, of plant output. Okay, next is the variance. Variance is the average of the squared distance from the mean. Okay, say for example, if you have certain data points with you, and you want to find the variance, what you need to do is you need to, for example, if the mean is 394, you can just quickly subtract these values, whatever the height of these individual animals are, and then square them together and divide it by the number of values. And this will give you the variance. So variance is nothing but the deviation from the mean square, right? The sum of the squares of the deviation of the mean divided by the number of data points, right? Now, if you see standard deviation and variance both are same. The only difference is standard deviation is root under of your variance. So once you calculate the variance, you can do a square root of your um, uh, variance, right? So once you calculate the variance, you can do the square root of your variance and it will give you your standard deviation. Now, why do we do, standard deviation, and what is the use of standard deviation if we already have variance? We need to do the standard deviation because once you do a root under, the actual unit was actually millimeter, okay? But when you do a variance, it actually changes to millimeter square. Now, when you do a square root, the millimeter is again the same unit as the original data set, right? So it's very easy to compare if we have the same unit. So that's the difference between variance and the standard deviation. Now, standard deviation will tell you how close the value is in a data set to the mean, right? So if you see the first instance, right, you can see these data points are, very close to the mean, right? Probably on the right hand side, some on the right hand side and some on the left hand side. So they have very small data deviation or standard deviation. So they are very close to, the mean. If the mean is 0, for example, these points are very close to the mean. So that is what we are telling you about standard deviation. Standard deviation is the deviation from the mean. Okay, how far it is from the mean, right? Say for example, if I am your instructor for, probably 3 months of your course, right? Or 2 months of your course. And every day I join at, 9:05 or 9:02. If your class starts at 9, someday I join at 8:55. Someday I might, join at 9:15, for example. That is not, the ideal time to join. But at times, say, for example, one day I joined at 9:15. So if you see closely, all of these deviation from the mean is actually your 9, which is your ideal time. And if I join someday on 9:05, it means I have a deviation of 5. Okay, not the standard deviation, but a deviation of 5. If I join at 8:50, I have a deviation of -10, right? So if you sum them all up, square them up, divided by the 20, if I have 20 classes with you, divided by 20 and take a root under, it might give you a result of, say, 1 minute. So it means that on an average or a standard deviation of, me joining the class is 901, right? So this is my standard deviation. So I have only 1 minute standard deviation from the mean. Okay. Now next comes where, as I told you, at times I might join very late, right? Very late, 9:06 or 9:07. At times I might join, 8:53 or 8:54. So this is a high standard deviation. So if it is spread a lot, it is a high standard deviation. If it has spread a very little, it has a small standard deviation. Okay. Now there are two things to understand. Whenever we have a statistics, right, we have two types of data. One is the population data and one is the sample data. For population, the standard deviation is where you divide it by the number of populations, right? So if, say, for example, if I'm taking the average age of all people from Bangalore, I'll, probably put down the population of Bangalore. Say, I don't know how much it is, 1.5 crores, right? Or 1 crore, for example. Say, for example, it is 1.5 crore, right? So I will put down, I will write, n is equals to 1.9. 1.5 crores, right? But if I am taking a sample of 1,000 people, in that case, my sample size, and I will divide it by n minus 1, which is 100 minus 1, or sorry, 1000 minus 1, if I have taken a sample of 1000 people. Why so? We will get to this in the subsequent class. It's a bit of derivation. I don't want to, go through those complicated calculations, but try to understand whenever we are calculating the standard deviation for a population and a sample, the denominator actually is n versus n minus 1. Okay. Now, the next metric we have is interquartile range. Now, what is the interquartile range? Interquartile range is the difference between the third quartile and the first quartile, okay, or the middle 50% value. Okay, so the IQR describes the middle 50% of the values when ordered from lowest to highest. So you have to do, you have to arrange the data in ascending order, and then you find the middle 50% of the value. This is called the interquartile range, Q3 minus Q1. So if you see, these are all quarters, okay, quarter, 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 right? But if we plot the quartile, we will have Q1 here, Q2 here, and Q3 here. So the difference between Q3 and Q1 is going to be my interquartile range. Okay. Now, how do we find it? Okay, obviously just through the diagram, you will not able to understand. How do we find it? Okay. Let's do it this way. Say, for example, you have a sample of data. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You have 11 data points. Okay. What you did is, divide it into two parts based on the median, right? So it is obviously arranged in ascending order. So the middle data is 17. So this is your 70, which is your median. Okay. And then this half is one data point, and this half in yellow is another data point. So 17 is your median. Keep it as it is. Okay. And then you have these 5 values. You again find the median, which is the middle value, and this is going to be 6. You again find the middle value of this particular data, which is 40. And here is where you got the quartile, right? So this is your first quartile, and this is your third quartile. So the difference between 40 and 6 is going to be your interquartile range, which is 34. Okay, so 34 is going to be your interquartile range. Once again, you have a sample data set. You take a median of that particular sample data set. What is median? Median is the middle value. So middle value is actually this point, right? You have 5 points here, 5 points here. So for 11 data points, you have 6th data point, which is your median, right? So this is your median. This is again your median for this data set, and this is again your median for this data set. So you have a Q3 and a Q1. You find the difference between them, and you have 34, which is your interquartile range. Okay. And then we move on to find the interquartile range. As I told you, this is your Q3 and this is your Q1. You create a box over here, and you can see this is your median, which is 17. And this is called your whisker plot. Okay, this is called your whisker plot. Okay, whisker plot actually helps you to find the interquartile range. Okay, now what are the benefits of quartile? Quartile will give you, what is the mean, what is the median, what is the interquartile range. So you can, have an understanding of if there is any, skewness in the data. We'll come back to what is skewness in the next later point of time, but try to understand what is skewness. Skewness is when your data is not spread, in a normal distribution. Rather, your data is spread with a skewness. Let's see with this an example. But what is the practical use of measures of spread? The measures of spread gives you an idea of how well the mean, for example, represent the data. If the spread of the value in the data set is large, the mean is not a representative of the data, as if the spread of data is small, right? So you have to have a data set which is too large. Mean will not be able to help you. Okay, so you have to understand this with more of a practical examples through measures of spread. Okay, let's look into the next one, which is measures of shape. Here comes our symmetric, skewness, and kurtosis. Okay, now Looking into this data, this is ideal situation. You have a normal distribution that have the same shape as both sides of the center are called symmetric, right? So this is a normal distribution where if you draw a line in between, you'll see just symmetric, you know, plots over a mirror. This is called normal distribution, and this is normal for ideal scenarios, right? For example, as I told you, if I will be your instructor for the next 3 months, for example, what will happen that I might join someday, 1 minute late. I might join someday, 7 minutes late. I might join 9 minutes late, or I might join, 10 minutes early. So if you take the, entire spread of dispersion or entire data set and plot it over a graph, you'll see that on an average, I will be joining somewhere around say 9.5 or 9.3, which is an ideal situation, okay, which is a normal distribution. So if you plot this, you'll see a normal distribution. And if you don't see this normal distribution, probably you should talk to your coordinator, and I might get a feedback, right? So this is called a symmetric diagram. Now, what is a skewness? When you see that, a lot of your data is towards, the right hand side, okay, this is called a positively skewed data, okay. And if you see a lot of these data on the negative side, okay, we call it a negative skew, or if you see this in the left hand side, negatively skewed. Say for example, if I join the class, very late, very late every day, I'm majority of the days I'm joining very late, you'll see a lot of these data accumulated here, right? Will be accumulated here. So in that case, I'll have a positive, you will see a diagram or a distribution like this. Or if you see me joining, very early, at times you will see that this is a negatively skewed data, because a lot of these data are present in the negative side of the diagram. Obviously, why this is negative and positive, this is your number line. You might have learned about number line in class 5, 6, 7, right? Here, if you draw a line, negative side will be this side and positive side will be this side. So positively skewed because data is in the positive side, negatively skewed because the data is in the negative side, right? Now, what is kurtosis? Kurtosis is something which again gives you an indication of the spread. Okay, if it is a normal distribution, we call it mesokurtic, right? We call it mesokurtic. If you see a lot of these data is present in your tails, you call it platykurtic. And if you see, ideally less of your data in the tails, but more towards the center, right? We call it the leptokurtic. Okay, so this is just the kurtosis. We will learn about kurtosis more in the subsequent classes, where you will understand that the normal distribution has a kurtosis is equals to 3, and leptokurtic and platykurtic has different kurtosis values. Now, as I said, this might be an instance where the data is spread a lot over the tail, right? It is spread a lot over the tail, so that's why this pink one is your platykurtic, and the one where it is spread towards the middle is called the leptokurtic. So this blue one or the sky one is actually your leptokurtic graph. Okay. Now, what is the practical use of measures of shape? A measure of the extent to which a frequency distribution is concentrated about its mean, right? So if you want to find out, outliers, a lot of these data will be in your tails, so you can easily figure it out. You can study the effect of outliers on the overall data just by looking into the shape of the graph or distribution. We are here at the end of this boring slide. We'll go to the plots. What type of plots do we have, right? So the first plot we will see is the frequency distribution. So for example, the make of vehicle driven by families in a community. So if you have a community and you see there a lot of people coming around and having a chit chat, you can just quickly see that how many people are using, say for example, Honda, and how many of them have a car Mercedes and how many of them have Maruti, and in total. So this is called a frequency distribution plot. Okay, this is a frequency distribution. Now if I want to distribute it, I will probably have a distribution which will give you a better pictorial understanding. Okay, now to gain the understanding of the spread, you can create a histogram. So histogram just gives you, the frequency of individual companies, car companies. So you can see this 3 is for Honda, 1 is for say Maruti, right? And so on. So this will give you a histogram. Okay, so histogram will give you a pictorial representation of the count of individual, items in a frequency table. Now you might have, data for, emergency response times of an ambulance, right? In here, you might have, you know, ambulance coming within, 30 minutes is 36 times, 30 to 60 minutes is 68 times, 60 to 90 is then 195 times, and so on. So you can create a histogram just to, present this data. So it's very easy to understand any data with pictorial format than, through tables, right? So this is actually how we try to do number crunching with pictorial representation. Next is your bar charts, that may be, vertically or horizontally created. Obviously these are different from your histograms, right? Because they are not connected. This gives you the understanding through bars. So you have individual bars for individual items. Next is the scatter plot. Scatter plot shows you the relation between one of the variables to the other. So when we start with our machine learning classes, we'll see, the correlation between two variables. So it will give you whether it's, positively dependent or negatively dependent. Okay, so scatter plot gives you the relationship between one variable to the other. So how one variable affects the other. Say for example, if the temperature increases, the humidity might also increase, or the sale of, ice cream will increase with the increase of temperature. So they are positively related. They are positively related. But if you try to find out, scatter plots um, of a different set of data, say for example, a political party 1 and political party 2, if they are, dire hardcore opposition, in that opposition to each other, then in that case you'll see if one party gets more votes, the other party will get less votes. So there is a negative relationship. Okay, so this is a scatter plot. Next is the pie chart, where instead of having um, data in a bar or a histogram, what you have the data represented through a 360-degree circle, and each of the parts of the pie will give you the representation of individual items. Say for example, average water use in home, right? 28% in toilet and 9% in bath and 20% in shower, 21% in shower, and so on. So this gives you a total 100% value. Okay, the pie chart will give you the data in percentage. Now coming back to box plot. Box plot is again same as, whisker plot, but again it will give you some understanding of the data in quartiles, right? And the good thing about box plot, is that it gives you the outliers as well. So if there are, outliers on the negative side or the positive side, you'll get to know about it through the stars over here. So it's the same as whisker plot, right? Q3 and Q1, you have the median value, right? Minimum value, which is not an outlier, maximum value that is not an outlier, and it gives you some understanding of if there is any outlier in the data, right? So a quick representation of box plot will help you to find if there is any outlier in the data. Okay, so if you plot this data in Python, or for example in Excel, what you'll get is you'll get the box plot where it says, what is the difference in the mean of all of these values, median of all these values, right? From here you can understand, but we'll go through much in-depth knowledge about box and whisker plots in the subsequent sections. So that's about the descriptive statistics part. Obviously very high level. We'll go through more of it in the classes. where we'll understand more on the mean median mode, how it is helpful to, you know, impute the data set, what are the different types of imputation methods which we have apart from mean. Will cover a lot about inferential statistics, which actually covers 70% of our statistics portion. We'll go through hypothesis testing. We'll go through different types of tests like one test, paired t-test, z-test, chi-square test, ANOVA test, and that too with examples like if you are a manager of a production company, right? um, do you need to tweak your machinery in order to make sure that it's giving you the correct output, or when to tweak and when not to tweak. It is okay to not tweak the machine if it is within a tolerance level, and that tolerance can be understood through hypothesis. Okay, so we'll understand each of them very thoroughly. As I said, statistics is the grammar of machine learning and data science. So you have to understand statistics. We tend to try to make it as much non-technical as possible, so that anyone who is from a non-technical background can also understand statistics, can also be comfortable with writing Python codes for statistics. And each of these tests which we are talking about will be you know uh, will have sections for theoretical as well as practical classes. Okay, so each of them will be implemented through Python. You will have a correct understanding of the inferential statistics part.